All right, here's assignment 2-3. See if I can get it focused in. Let's do it together. So question number 1. And again, we're deriving implicitly for this lesson and assignment. And then there's some review questions. So can we take the derivative here? That's 2x and 2y, but it needs a y prime. You need that hook on whenever you take the derivative and y is involved. The derivative of 4 is 0, and then get y prime by itself. So subtract 2x, divide by 2y, and you have your answer. Number 2. Be careful here. xy means the product rule. So we have the first and the second. Put a dot there. Remind yourself. So the product rule is the first times the derivative of the second plus the second times the derivative of the first. And that's it. And then the derivative of 7 is 0. So to get y prime by itself, we're going to subtract y. And then we're going to... Oh, what is this? This is y prime. And then we're going to divide by x. So it's negative y over x. Number 3. We have x cubed. Subtract 2. No, I'm reading the wrong one. X squared. Let's try this again. So x squared y cubed plus y equals x cubed. Alright, so we're going to derive implicitly here. So we're going to do the product rule. So we have x squared and y cubed. So the first times the derivative of the second, but I need a y prime, plus the second times the derivative of the first. I don't need a hook on for when I take the derivative with x involved. The derivative of y is 1, but we need a y prime, and then 3x squared. So do you recognize the terms that have y prime in them? We're going to factor out the y prime, be left with 3y squared, divide, and you're left with 1. And then everything else is going to the other side. So we're going to... Oh, wait a second. What did I do here? This is all together. So 3y squared, x squared, that's all together, plus 1. Then we're going to subtract this to the other side. And then the last step is we're going to divide. So we have 3x squared minus 2xy cubed divided by this. So I'll put them in order. 3x squared y squared plus 1. Number 4. Trigonometry. Here we go. What's the derivative of cosine x? That would be negative sine x. What's the derivative of negative 2 sine and so on? So it's first going to be negative 2 cosine 2y times, what's the derivative of the inside? 2y prime. And then the derivative of 4 is 0. Alright, now we're going to isolate y prime. So I'm going to add sine x to the other side. And here, I'm going to divide. So if I put this together, 2 times negative 2, that's negative 4 cosine 2y. So I'm going to divide by that. And there's your answer. All right, number 5. All right, step 1. Take the derivative of tan, that's secant squared xy times. Now, I'm going to use parentheses here. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first. And then y squared is 2y, but it needs a y prime. So I'm going to distribute here. So if I multiply this together, I got x times secant squared xy with a y prime. Y times 1 is y, so I have y times secant squared xy is equal to 2y y prime. Alright, I'm going to subtract this to the other side. And I'm going to subtract this to the other side. Now I'm going to factor. So I'm going to factor out a y prime. Oops, I forgot. There's a y prime here. I'm going to factor out a y prime. So I'm left with x times secant squared xy minus 2y. And then the last step is to divide. And there's your answer. Number 6. Step 1 is to make this calculus friendly. So that's x to the half and y to the half. Then take the derivative. So it's 1/2 x to the negative half plus 1/2 y to the negative half, but it needs a y prime. And the derivative of 9 is 0. We're going to subtract. And then I'm going to divide. Oops. Alright, so now this is the answer. Now we can simplify this. The 1/2 does divide out. A negative exponent. Oh, which one's x and which one's y? This should be y that I'm dividing by. Okay. So the answer is negative. But y to the negative 1/2 is the square root of y, and it goes on top. X to the negative 1/2 is the square root of x, but it goes to the bottom. And there's your answer. Number 7. Take the derivative. On this side is going to be the quotient rule. That's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and the bottom squared. Combine like terms. X times 1 is x, and x take away x means they eliminate. So all I'm left with is 1 times 1. So when I combine like terms, that's what I'm left with. When I divide, oh, where's the y prime here? When I divide by 2y, it just joins the other denominator when I divide it. And there's the answer for the derivative. Number 8. So I need to take the derivative and then plug in the point. Be careful, this again is the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. The derivative of 3 is 0. I'm going to, this is negative y, so I'm going to add y and subtract 2x. And then divide by negative x. So there's my derivative. Did I do something wrong? I did do something wrong. This should be x cubed. So it's y minus 3x squared when you take the derivative. All over negative x. And then take the derivative at 1 negative 2. And this is negative 5 divided by negative 1 or 5. Number 9. All right, take the derivative first. 3y squared, and it needs the hook on. 2y, and it needs the hook on. And 2x. Next, factor out a y prime here. And subtract 2x. And then the last step is to divide. Then you plug in the point. So if I plug in 2, I get negative 4. If I plug in negative 2, I get 12. Take away 4, that's 8, so that's negative a half. Number 9, I did number 9. Number 10. X cubed plus y equals 2xy. Take the derivative, 3x squared. The derivative of 1y is 1, but it needs a y prime. This is a product rule. So the first times the derivative of the second plus the second times the derivative of the first. Subtract 2xy prime so that those y primes are together. You have 2y, and you're going to subtract 3x squared, and then divide out the y prime. And then there's the derivative after you divide. Now we have a point. 1, 1. So plug in 1 for y and 1 for x. 2 take away 3. 1 take away 2. And then the answer is 1. Number 11. Secant x plus y Alright. The derivative of secant is secant tangent. And then what's the derivative of what's inside? So the derivative of x is 1, and the derivative of y is 1 y prime. The derivative of x is 1, and the derivative of 1 is 0. So there's a good start. I need to get y prime by itself, so I'm going to divide. After I divide, I'm going to subtract 1. So I have this. And then instead of adding 1, I subtracted 1. So now y prime is by itself. And now I'm going to plug in the point 0, 0. So 0, 0 means I need to know at the angle 0, secant is equal to 1, the reciprocal of the x, but tangent at 0, y over x, is equal to 0. This is undefined. And it's done. Because this answer is 0, 0 times whatever is 0, so it's 1 divided by 0, take away 1, the answer is undefined. So the derivative is undefined. Number 12. So again, it ends up being 0. So the value of tangent at 0 is 0. So it ends up being 0 times 1. That's 0. That's why it's undefined, because we have a 0 in the denominator. Number 12. Differentiate implicitly. X squared plus y squared equals 25. Get y prime by itself, subtract 2x, and divide by 2y. And then the derivative at 3 negative 4 would then be negative 3 over negative 4, or positive 3/4. Number 13, use explicit. So you have to solve for y first. So if I solve for y here, it'd be y squared equals 25 subtract x squared, and then take the square root. Now the answer could be positive or negative. I want you to notice that the y value here is negative 4. So we need to find the negative here, so that when I plug in 3, the answer is going to be negative 4. So the answer could be positive or negative, but this y value tells me it must be negative on the outside, so that when I take the derivative of this, it's negative. We have negative a half, and then subtract 1 is negative a half, and then the chain or the hook on, the derivative inside is negative 2x. I could simplify this. A negative times a negative just gives me x, and then in the denominator is the square root of 25 minus x squared. At this point, I can plug in the point 3 negative 4. So that would be 3 and 3. I don't need the negative 4, just the x value. So 3 squared is 9, so 25 take away 9. So it's the same answer. One doing implicitly and the other one explicitly. So 12 and 13, you get the same answer. Number 14, turn the page. We have x squared plus xy equals 4. We want to find the second derivative here. So we got to find the first derivative. This is the product rule. The first times the derivative of the second. The second times the derivative of the first. The derivative of 4 is 0. So we're going to subtract 2x and subtract y and divide by x. So there's my first derivative, negative 2x, subtract y, divided by x. The second derivative is going to be the quotient rule. So that's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. To put the answer in terms of x's and y's, I need to replace that. So y prime is negative 2x minus y over x. I'm not going to try to make it look pretty. It is what it is. And there's your answer. So we know what y prime equals, so just replace it. And now the second derivative only has x's and y's in it. You could simplify it further, but it's not necessary. Number 15. Find an equation of a line tangent to x squared plus y squared equals 169 at negative 12 and 5. So to find the equation of a tangent line, these are the three things I need. So I already know this. I need to take the derivative and get y prime by itself. And then I need both. So I need the x value and the y value. So a negative times a negative, that's positive 12 over 5. Put it together. So the slope, it's plus 12 plus 5. Done. Number 16. In number 16, there it is. We have an equation, and it says to find the horizontal tangents. So I need to take the derivative. And then I need to get y prime by itself. So I'm going to factor out a y prime. I'm going to subtract 2x and then divide. So there's the derivative, negative 2x, 4y minus 4. Now a horizontal tangent would mean the derivative is 0. So take the numerator and solve it. So when x is 0, the whole derivative is 0. And then I need to go back and plug in to find the y value because it asks for the points. So if you plug in 0 for x, you're left with 2y squared minus 4y minus 6 equals 0. So I need to solve for the y coordinates, divide everything by 2, factor it, and then the two answers are positive 3 and negative 1. So to put it together, the points are 0 and 3 and 0, negative 1. So at those 2 points, that equation has horizontal tangents, which might mean that there are turning points at those 2 if I was graphing it. All right, number 17. Oh, same question in 17, but the question says a vertical tangent line. So vertical means the slope is undefined. So look at the denominator, make it equal to 0, and then solve it. So when y equals 1, the denominator is undefined, right, 0. And then take that answer and plug it back into the equation. So for y, you plug in 1. You're looking for the x coordinate for that. 2, take away 10, what is that? Negative 8. So when you square root, the answer is both positive and negative root 8. So it'd be positive and negative root 8 and 1. Because that's what the y value is. So there are 2 points where the slope is vertical, so that we have an undefined derivative. 18. In 18 it says the volume of a sphere, and it says take the derivative with respect to the radius. So 3 times this, the 3's would cross out, and subtract 1 to the exponent. And then it says when the radius is 4. So if I plug in 4, that's 16 times 4, that's 64 pi, and that's it. Number 19. So these questions are looking off a graph, so we'll just do it. I'm going to write down the question, the limit as x approaches 1 of f at x, and then I'll look off the graph. So find 1. So the limit there is the y value of the whole, so it's 0. For number 20, the limit as x approaches negative 3. You should try it first, right? And then press play. So find negative 3. So the answer there could be infinity or doesn't exist. Number 21, the limit as x approaches negative infinity. That's the left end behavior. So what's happening at the left end? What is it getting closer and closer to? What's the y value it's getting closer to? It's 0. Number 22, the limit as x approaches 2 of f at x. So I see 2, there's a jump at 2, so the limit doesn't exist. 23, the limit as x approaches 2 from the right. So only looking from the right. So here's 2 from the right. What's the y value? That's 1. List the x values of discontinuities. And then, alright, so at x equals negative 3, at positive 1, 2, and that's it. So those are the discontinuities. We have a vertical asymptote and 2 holes. At 25, which one are removable? So where does the limit exist of all this? So the limit exists at 1. So it's a removable discontinuity. Why? Because the limit exists there. 26. Where can you not take the derivative? So all the ones we just listed, negative 3, 1, and 2, those are the discontinuities. You can't have a derivative at a discontinuity. Are there any sharp turns or corners? So at negative 1 is a sharp turn or corner. And here we have a vertical tangent line, right? So it's continuous, but the slope is undefined, so also at 3. All right, 27, it's going to use a calculator. I got one of those, and it says, solve that inequality. Let's see if I can do that with my calculator. So I'm going to go solve. So algebra solve. I'm going to type it in. Where am I again? 2x squared. Subtract 7x plus 4. Now I want you to press Control and then equals. And then find the correct sign. And then go comma x. And there's your answer. You could also write the answer as a decimal. That's all right. The three numbers, 0.719. .780. We don't have to round. You could also just write it this way, and it's the same answer. 28. An object's velocity it says find the object's speed each time the acceleration is 0. So to find the acceleration, that's 6t squared minus 18t plus 12. I'm going to divide everything by 6. Then I'm going to factor it. So at 1 and 2, the acceleration is 0. And so I need to plug 1 into here. That's what? 2 take away 9 plus 12 take away 5. What is that? Negative 7, positive 5, 0. So first time the velocity is 0. And that would be meters per second, or it's resting. And then at positive 2, again, I'll do the work, but you'd plug positive 2 in for t to find the velocity at that time. And if you did that correctly, you get positive 1. And again, because it says speed, right? This would be, now 0 is 0. But here, if you had a negative answer, you do the absolute value of that, and it become positive. Because we're talking about speed and our units. 29. Almost there. Alright, the derivative of this is just the derivative of that. What I would do first is I would write it as 2 fractions and simplify each one to make it easier. So that would be 1 minus 2. Now we're left with an x in the bottom, so we write that as a negative 1. And then the derivative of that is 0. Negative 1 times negative 2. Subtract 1 to the exponent. You could also write it this way, and there you have your answer. Number 30. Sketch a graph of this. Let's do it. X subtract 1. X squared, take away 1. And then graph this. So I'm going to plug 0 into the top and get negative 1. And then the slope is up 1 over 1. So this is what it would look like. Going up 1 over 1. The next one's a little piece of parabola. Plug in 0 and you get negative 1. It's there. Plug in 2 and you get 3. It's a hole because of the arrow. And then these connect. That's a little piece of a parabola there. And then 4 is a constant, just a horizontal line at 4. And there it is. The next part is, we're going to do some limit questions based on this. So what's the limit as x approaches 0 of g at x? So at 0 the value is -1. 32. What's the limit as x approaches 2 of g at x? So here's 2. There's a jump at 2, so it doesn't exist. 33. What's the limit as x approaches 2 from the left? So from the left, the y value here is 3. 34. What's the limit as x approaches 1? So as x approaches 1, that's the middle piece. So if you plug 1 into the middle piece, the answer here is 0. Alright, 3 questions left. List all the, so we still working on this. List all the discontinuities. So there's only one right here where the hole is at 2. So at x equals 2 is a discontinuity. It says find the derivative of g at x. Let's do that here. So you just got to take the derivative of each piece. So x subtract 1, the derivative. This would be 2x. And the derivative of 4 is 0. So there's the derivative. What was that? 36. And then 37. List all the values where g is not differentiable. So it's not differentiable where there's a discontinuity at 2. Also, if I plug 0 into the top, and 0, there's a sharp turn at 0 where they don't agree on the derivative. And that's it, right? Just at 2 and 0. That's all I got. Yep, that's it. All right, Mr. G Math. Make sure, right? We're done? We're done. That's the last question. Mr. G Math over and out. I'm proud of you for doing your work. Until next time.